Okay, I think it's time to start right now. Just a second. Okay. First of all, I want to say hi. My name is Pablo Aguilio. I work for Galileosky. I'm a technical support engineer. Today, we like to talk about those important topics. We didn't talk much about these new features that we were working on. I mean, so today we think it's a good time to start telling you about these new features. It was features that clients asked before. So we are very proud, we are very happy to show you these new features today. First of all, our webinar will be about 60 minutes long, maybe a little less. I want to show you just the main topics, these two features, but the base topic, the base idea of it, and how they work, and maybe you can get some ideas on how to use it. Okay, so it will be 60 minutes long, as I said. You will receive the recording of this webinar after finishing in your email, the email that you use for registration. And most probably you will find it also on YouTube, in our YouTube channel. It would be a good idea also to subscribe to it and to follow us in our YouTube channel, so you can be up to our news, to our new features and webinars and some courses that you can find there. So as always, I recommend you to subscribe to the channel. Okay. Of course, there will be time for questions. There will be time for discussion, let's say. I'll ask you to write in the chat if you want to make a new question, or you will find a question tab. You can leave the questions there. So every question you have, I will try to answer, of course. And if I don't have the answer, or I need to ask my colleagues, of course, you can contact us, as always, on support at Galileosky.com. And there you can ask everything you need if you find some problems using this new feature or other features, or maybe you are working on a new project. So you can always ask us and ask for help to continue your new projects, to develop your new projects. So you, as always, you can count on us. Okay. Okay. First, as always, I'd like to talk you about news. Our recent news. Galileosky is a company that is always moving. So we like to tell you what's happening with us, and in which area, in which new projects we are working. So as always, we like to tell you what we did. Okay. Recently, we released a new version of Configurator. Configurator has a new file editor function. As you know, using 46 firmware or newer, or using Galileosky 10 devices, I will talk about them later. You have the option to access the SD card inside the device directly from USB connection. Okay, so this new feature allows you to write directly files or read files inside the memory that are saved inside this memory. Okay, so that's a new feature. Also, we are working on fixing some small problems that we find in the previous version of configurator. And as you know, we release from time to time, release new version of configurator. As always, I will recommend you to keep you updated, to use the latest firmware, latest configurator, because when we find some problems or when we need to add some new features, we add them to the latest version. So it's good to be up to date and to try to understand the new features that we are releasing. Okay, so you can start testing with them, working with them, and try to develop your projects on using these new features that always might help. Okay. Also, I'd like to tell you about our visit. We were in Brazil. Ignacio was there, our manager for Latin America. He was there with our partners from SG Bras. Of course, we'd like to we are very grateful because of the way that they receive us. So we are pretty happy, as always, to visit Brazil. And we were there discussing with new clients, new features and new projects that they have. So it was a very interesting meeting, as always. And also to try to understand the needs that Latin American market has. It's always good to see. It's always good to be among friends. Okay, so we are pretty happy to participate in these conferences. And finally, I'd like to tell you about our, let's say, our latest son. I'm talking about Galileosky 10. It's our new device. It has incredible features. For example, it can parse SHA 1939 data directly, in which you can get up to 13,000 new parameters. So it's a huge amount of information that you can use for your projects, as always. So we are pretty happy about it. Also, you can follow the link. Thank you, Natalia. You can follow the link to meet our device more deeply. It has integrated 4 gigabyte eMMC memory, so you can keep your data inside this memory, but also you can keep maps, I mean geofences, you can keep data, you can keep data that you get from other devices using hub-to-hub feature. So it's a great add that we decided. Also, devices, Galileosky 10 devices has more RAM memory, so you will have less problems when you want to run some RAM-intensive scripts. Okay, and also we are working on our 10 Pro devices that will add more RAM for more complex script. So we are very happy and very hard working on these devices. Okay, also these new devices add more tracking precision, up to 30%. They are more compact, they are more light, and also they use USB-C connectors. So when you are working in difficult places, when you are working inside the machine and you need to put your arm inside some strange place in which you install the device, it will be easier to connect using USB-C connector. So that's that's an interesting add that we decided. And so, as I said, we are very proud, we are very happy about it. And of course, we are still working on getting better features, and to work it, to make it more stable. So we are happy, and we are very hard working on it. So okay, that's what I wanted to say about our latest news in the company. And I want to start right now with the topics. I mean, that we decided to present to you today. What about transport message system? Okay, transport message system is new feature that we have, in which devices communicate between each other. Okay, that's the main idea, that one device can send an event when something happened to other device. Maybe the second device can answer to the first one. So before, we used to send data only to the monitoring server, and that's it. And we keep the data, and we know, I don't know, for maybe the speed of the vehicle, maybe position of the vehicle, or maybe it's a stationary installation, and you send some data about this installation, and that's it. You receive it on the monitoring server, and that's it. With this new feature, we can communicate one device and tell one when something's happening, and the second device can take actions according to it. So, for example, I'm showing here two simple examples, but of course it depends on your imagination, or maybe it depends on your needs, what you can do with this. Okay. For example, we have this first example in which this machine gets the grain from the field and put it in a truck. Okay. Then this truck goes to the elevator and unloads all the grain that it has to this, for example, this place in which you store the grain. So what we can do here, for example, we can have a scale in the truck, in which we start getting the weight of this grain that we obtain, and then we go to the elevator, sorry, and you unload all this grain. But using this new feature, you can communicate the device that you have in the truck and the device that you have installed in the elevator, and you can send data saying, okay, my weight, or the weight that I have, that I load inside my bag. It's I don't know, for example, 10 tons, and then you can compare with the data that you obtain in the elevator, and you can use this new feature. Before, you need to do this kind of things by hand, right? You have the data in your monitoring server, and you compare, and you say, okay, it's the same, or more or less it's the same, it's okay. But using this feature, you can communicate to the elevator and say, okay, the amount of grain that you will obtain is this amount. For example, as I said, 10 tons, okay? And if you receive less, you can try to compare, and or maybe generate an alarm, or maybe communicate, or try to understand where's the loss. But in general, you already have the information, and you already have and the elevator already knows that there are some difference between the load that he must receive and the load that he obtained, right? That's just an example. Also, we have this example below. This example, for example, this type of device, it's a device that measures humidity of the soil. Okay. For example, we can use this kind of devices. We install different devices like this in different parts of the terrain of the field, and we measure the different variables from the soil. And if something happens, we can send an event to the devices that are in charge of um, putting the water in the field, let's say, okay? You can automatically, without user intervention, make these things automatically, right? So it's an interesting feature that you can add just using this new feature. Okay. Now I will talk about a little about theory, right? About how the structure of this system, how it works. The main idea is that you have a group of projects, okay, in which all the devices that we will use for this function are contained, right? We have this, like this, the group of projects. And then we have projects in which we can put different devices. For example, just thinking, in project 1, terminal 1 and terminal 2 are different installations to measure the variables of the soil in the field. Okay, so we will have different sensors connected to these terminals. That's one project, just an example. And then you have a second project in which you have the machines in charge to water the field, right? And we have, instead of a sensor, we will have an actuator. That's just, again, it's just an example. So you can manage the different, let's say, the different types of terminals, the ones that get data and the ones that actuate, the ones that do actions on the field, and keep it in different projects, but inside of a group of projects in which they can communicate between each other, right? Which limitations we have with this structure? All terminals must be only under one owner, right? And these devices cannot be using group share option, group usage, pardon, group usage option, right? So it must be owned by just one owner, let's say. Okay. And the second limitation is that we can have multiple projects, as I said before, but we need we can construct just one general group of projects. Okay, just only one, and multiple projects. I give you the example with 2 projects, but it can be multiple. Let me check. I think we already have questions. Okay. I will answer to that later, Aldo. Thanks for the question. That's about the structure. Let's continue. The working principle. Working principle. It's which blocks we add to the easy logic algorithms. We have 2 new blocks. One is called run event. It's the block that will generate the events for others to listen. And then we have this other block called incoming event, in which we receive the data coming from, the publication done by other device, right? The options that we need to set in each of the blocks, it's the group of project, as I said before, the project to which it belongs, this device, this event, event name, right? Which it will be the same as on the receiving device. And then we have the left time, which is let's call it the time to live. You send this, let's think about it like publication and reception structure, right? So the devices that generate events are the ones that publish, right? They publish events and they put it in some place. I will tell you a little ahead where you put these messages. You publish, right? There are some devices that publish them, put this data in this server, and there are others that are called subscribers that connect to the same server, and they just listen, right? When there is a new publication, they are subscribed, and they get the new information, right? And then we put some arguments. You can use any argument, any variable you have in your EasyLogic script. For example, I'm using the voltage of the input, right? And on the other side, oh, sorry, this left time is the time to live, I was saying. After this time, the message will be deleted. If the subscriber didn't get the data, the message will be removed, let's say, from the server. But new data can be sent all the time. But it's just to be sure that the event was received by the subscriber, and if it was not received, it will be just removed from the server. So we set some time to do that. On the other side, we have this new block called incoming event, in which we receive what was published in the server, right? You can use this block just to get arguments, just to get variables from the other device, but you also can execute commands, right? You can use it as a command, as a normal command block. So after starting the reception of this incoming event, you can execute some actions, open or close an output, maybe turn on some bulb, maybe make some machine to run. So it depends on you what you are planning to do, or maybe send some data. It depends on you. And the parameters that you need in this block is to be in the same group, as I said, to belong to some project, and you will use an event filter to be sure to which message you are listening to, and some arguments, right, that you do receive from the other device. Now let's talk a little about the settings that we need. You need firmware 45 or newer, as I said before. It's one of the requirements for devices 10. It's already it's also available too, and you need to activate transport message system. As you know, not long ago in our firmwares, it's available this new tab called System, in which you can enable or disable different services that maybe you will use. For example, maybe you don't need to use CAN bus data, so you can disable it and save some RAM, so you can run more bigger scripts or more complicated scripts, right? Or maybe you can disable Bluetooth if you don't need it. It depends on you. It depends on the needs that you have for your for your project, right? And this option is disabled by default because of that. So if you really need to, you need to go to System, enable it, and then restart the device. And after that, the device will start working and will start getting and connecting, or maybe it will have the possibility to connect to the server. Okay. Now about configuration, right? As I said, you need a server to do this, right? So the device will connect to this server, and you need to send this command here. Of course, you can get all these commands, as you can see, are quite complicated, but you can check in our knowledge base, in which you have all these commands, all the information, of course. So you can go there and copy, paste, and use the commands directly. You need to first connect to the server using this command over here, and then you need to run these 3 commands here to receive the public token. I mean, it's one of the ways that the device can obtain the data from the server, right? To in some way to identify himself as a device that will connect to the server. And then you have a secret key that is over here that you also need to run. And after running these 5 commands, you are ready to operate with the device. With this new feature, let's say. Okay. About transport system, that's all. But I would like to show you how it is working. I have a small project over here. Okay, it is running here. I think you can see the screen right now. Okay. I have 2 devices here. Both of them are connected. And I wanted to show you. Okay. I wanted to show you some ideas, how I implemented this transport system. What I did. Okay, on this side of the screen, I have the generate event logic, and on this side of the screen, I have the receive event logic. The generate event will just try, but it will receive a command, which is send event. It will wait some time, and then we'll try to run event, as I told you, using a group, project, an event name, and some time to live time that I set to 60 seconds, and I will send this input 0 voltage, right? If it's correct, the device will answer that the command run well and everything went fine, and then finish, okay? And if something fails, maybe the device is not connected at that moment to the server, so it will show this error that I cannot send the message, and you can retry. I just finished the logic, but you can try to retry. If you detect that there's some error, you can retry after, I don't know, 20 seconds or something. It depends on you. And on this side, on the left side of the screen, I have the receive event logic, in which I just receive the message, right? I have some event filter, and I put this voltage that I receive in this argument, in this variable, right? I will present it using a diagnostic message, and that's it. I will go out from the logic. Let's go to troubleshooting first. I want to show you some stuff. As you can see, you there are some messages appearing all the time here. For example, this one, GS broker, in which the device is trying to check if connection with the broker, with the server that contains publications, it's online. So it sends a ping, and the server answers with the pong just to say everything is fine, everything is connected. And here you can see it disconnected for a small amount of time and then connected back, and you can see how it established the connection. And you can see here, I will show you here, it is subscribed, right? It is subscribed to some to this event, right? This event that is called input 0 voltage. So he's waiting for to get information on this specific comment. And on this side, the device that sends, it shows nothing. It just connects, right? But it's not subscribed. It's just saying, okay, I'm connected. I have a live connection with the server, and I just show that I'm connected, and that's it. Okay, let's try now to run some command. Let's go here. We have this command here, and we send the event. If we go to troubleshooting, we can see that it will generate the event. Here is the event. It was received. Okay. Okay. Something happened with the receiver, or I was not able to check. Let's try again. Okay, it was generated. Okay. Okay, it may fail. For some reason, the receiver lost connection to the server, and he didn't. Okay, let's try. Let's wait a little until it tries to connect back to the server. Okay. Okay, that's something strange. Okay, now we are connected back, as you can see. Let's try again. Okay. Well, it was working, I must say, but it may fail. So maybe I have some small problem with the connection here, so that's why it is not receiving the proper command. Let's try again, just once. Okay, yeah, it receives the command, but for some reason, it's not. The subscriber cannot get a connection to it. It's a pity. I wanted to show you how it works, but it was working before. But this kind of thing happens too. Okay, let's go back to the presentation. Okay, now I will talk a little about Modbus, but at first in general, for those who never worked with it, Modbus is it's a protocol to communicate between devices. It's very common in manufacturing and industrial environment because it was created about 40 years ago. So it's very well known. It's very reliable. So every device working on this kind of environments must must be compatible with this kind of protocol, right? It allows to integrate equipment from different manufacturers. It works on a master-slave architecture, so you have one master device that creates requests and then send it to the bus. So the device that is requested, let's say, by the master will answer, and the other will just listen and just stay, right? So every request are made by the first. I mean, it's formed by the slave number, the data that you want to get. I will talk a little about that later, and CRC and some and the size, of course, the size of the data that you want to get, and some CRC, and that's it, right? So it's very common, very reliable, and it allows you to control sensor, control relays, and different type of controllers. Usually works on RS 485 and RS 232. But as Modbus is so in the same idea as the TCP model, based on the OSI model, OSI model, this Modbus can be used in another way, and that's what we will talk today, but a little later. Modbus works on registers, right? You have different kind of registers to which you can ask the slave to answer. The first of them, coils, is just bit registers in which you receive if the coil is open or the coil is closed, just 0 or 1. So you ask them, and they will say, for example, device is on, right? Or device is off. So you will get a 0 or 1, and just that's it, right? And you can also write on them, so you can use them for turn on or turn off a device, or maybe change the state of some output. Then you have discrete inputs, which is the same, but you can just read them, right? So you can check if a switch is closed or it's open, and you read them, and the device, the slave device, communicates the state of this input to the master that made the request. Then you have holding registers, in which you can keep any data you want. In general, they are formed by 16-bit, but you can request bigger registers, so you can communicate with, you can get float, for example, 32 bytes. You can ask for 2 registers, so you can get 32 bytes, and you can work with float. You can work with integers, but 32 bits or 16-bit or 8-bit, so it's very comfortable to work with them. You need just to select which kind of register or which size of register you can work on. This kind of holding registers also allow you to write, to send configurations to the slave devices. For example, change the way or the unit in which the data is presented. So you write in this register, and the device will understand that you want to change the way that the device communicates. And also, you have input registers in which you get only data from inputs, right? For example, voltages. Our devices work with Modbus RTU or ASCII in devices 7X from firmware 24/7 and go on. So it's a long time that we were working with Modbus RTU. But now, as I was telling you, Modbus can be mounted on a different structure in the OSI paradigm, let's call it. So we will start talking just some time ago. We are talking about Modbus TCP server. So the idea is that you can get Modbus information from Modbus RTU networks or from Modbus RTU buses and show them in devices that are connected to TCP networks, right? And you get directly the data from RTU and show them in system like SCADA, right? Or HMI, which connect to the IP network, or PLC, which are connected to the IP network too. And then and they will ask and can get information from the RTU bus on the other side. What's new about this feature? Okay, our devices using this new feature, using this new script that we developed, can get data from RTU, as you can see here, connected to RTU, or different devices that works as Modbus RTU servers, and then and get that data and send it to the Modbus TCP server. So it will transform, let's call it, the data coming from analog signals or from RTU, other RTU connections, and transform it, mount it as you wanted, to call it, to the TCP type of network. So it would work as a Modbus TCP server, but not only that, it would work as a RTU gateway. So it can get, as I told you, it can get data from RTU bus and show it to TCP clients. And that's the main idea of this new feature that we are presenting today. The configuration that we need for this kind of operation is 7x hub, right? This 7x hub. One second. This 7x hub has the Wi-Fi connection, so we need this kind of connection to work with it. We need a sensor with Modbus support, right, to connect to the device. And we need a device running OPC, Open Platform Communication Server, for example, SCADA system, as you can see here, to get the data coming from RTO bus on the other side of the network. And also we need a Wi-Fi access point, of course, to communicate the data coming from the other part of the network and work as a gateway, connecting the Wi-Fi network to the device. Okay. After that, you will use this script described here. There are some special things that you must have in mind. For example, this script is designed to work at a specific speed. I mean, specific speed for RTU communication. So if you need to work on another speed, it works by default in 19,200 PPS. But if you need to work in another speed, you can use the same script, but you need to send some comments. You need to wait for the script to wake up and then send some comments, or maybe you can create your own script in which the settings, you execute the commands that you need in order to change configuration of the script, and you can connect to your device. Okay, that's the main idea for it. It's an interesting feature, I think, and of course, as it's a de facto standard, as it was written on the presentation, for this kind of networks in manufacturing, in industrial environment. It's a pretty interesting feature. Also because cost for this kind of devices, for this kind of sensors and modules that work with this protocol are pretty expensive, and so it's good. We can get, using Galileosky devices, we can get a good balance between the money spent, money invested for your solution, and the results that you get. So we think it's a pretty interesting feature. And also it's interesting, as I said, to communicate in some way different devices, right? Okay, I will go right now to the questions. I have a previous question from Aldo. Aldo asked me if when will the firmware 1.2 be released for 10? I think very soon. I don't have the exact date, but we are working on it, and I think pretty soon it will be released. Just keep in touch. We will communicate. If you need to, you can, as I said, you can send us an email, support@galileosky.com, and ask us there, and we will try to contact you back when we have news about it. And also you can find us on our page, galileosky.com. There's a chat, and you can find me, or you can find one of my colleagues, and we will try to answer all your questions, not only technical questions, but also commercial questions, and try to find, we have a new feature in which you can design your own solution. Maybe you have something in mind, but you don't know how to implement it. So you can ask us, and we can develop some solutions by yourself, and you can arrange that. We have some more questions. 1 second. Does the new 10 devices have Modbus support? Yeah. Although they also have Modbus support. No question about it. Yeah. Modbus RTU, and you can use Modbus TCP using the same configuration that I already told you. Juan Arenas. Will the recording of the presentation? Yeah. The presentation will be sent to you. But also it will be available on YouTube, most probably in the next week, probably. But keep in touch, and also remind you to subscribe to our YouTube channel, so you can get the latest news about our company and our devices. Another question: it can using you can use 7X as a Wi-Fi IP. Let me think about. He's asking me if we can use 7X as a Wi-Fi IP. Okay. Okay, 1 second. Okay. Oh, I have more questions here. Okay. He's asking me if we can use the 7X as an IP, not as a client, but as an IP. So the TCP client connected directly to TCX Galileosky 7X TCP server without over Wi-Fi point. By now, no. I'm pretty sure no. Our Wi-Fi IP feature is more to work with the hub-to-hub feature. I mean, it can work as a client, so you can connect to any IP, or work as a hub-to-hub configuration in which two devices send data between each other. If you want to check about hub-to-hub configuration, we have a lot of videos, but the main idea is that one device that cannot connect directly to the monitoring server can send its data to another device that will receive the data, and then when the connection is available, he will send it to the monitoring server. Not on his name, but it will be it will send the data to as the original device that received the data. And on your question, Resi, I think that by now, no, but maybe it's a good and interesting question. So I will talk with my colleagues about it, and we will have that in mind. Thank you for your question. Do we have any more questions? I think by now, no. Okay, okay. Okay. As always, if you maybe not right now, maybe after watching the video, something it's not very clear to you. So, as always, you can contact us on our webpage. There's a chat there. Maybe small questions are we can answer them very fast, so you can maybe some small detail you can ask them there and we can answer. But if the question is more complex, I would recommend you to create a ticket at support@galileosky.com, and we will be happy to help you. And also you can contact us on our at our company at the time you want. Okay, if there is no more questions, there's some more question. One sec. Thank you, Natalia, for writing down the email. And so I think for today that's all. Thanks you for being here, for being present. I'm very happy to stay in contact with you. And so I hope that we can meet soon again and discuss new interesting future and new interesting ideas that we want to present to you, so you can work on your own projects, right? Thank you, and good day, good afternoon, good night, and see you soon.